Hello, this is MEI Further Maths Core Pure. We're in the first matrices section and on the first video on basic operations with matrices. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. A matrix is just an array of numbers. It may represent data or other mathematical information such as transformations. We define its size by the number of rows and columns, giving the number of rows first and then the number of columns. To remember this, you may find it helpful to note that R comes before C in the word matrices. This matrix gives us information about football results. Here are some more matrices. A and B are square matrices because they have the same number of rows as columns. In print, matrices are written using capital letters in bold font. In handwriting, strictly speaking, you should underline the letters to represent bold font. If we want to add matrices, they need to be the same size and shape. We then say they are conformable for addition. Conformable means slightly different things depending on the operation. Basically, it means that the matrices are the right size and shape to do what you want to do with them. Adding matrices is very straightforward. If I want to add matrices A and B, I just take each element in turn and add it to the corresponding element in the second matrix. So in the top left I've got 2 add minus 4 is minus 2. Top right, minus 3 add 5 is 2. And then bottom left, 4 add minus 1 is 3 and 1 add 2 is 3. Pause the video for a moment while you work out B plus A. OK, for B plus A, we just write the matrices the other way round and add them as before. Top left, minus 4 add 2 is minus 2, 5 add minus 3 is 2, minus 1 add 4 is 3, 2 add 1 is 3. And unsurprisingly, we get the same answer as if we'd done A add B. Matrix addition is commutative. It doesn't matter which way round we do the sum. That might seem obvious, but when we look at multiplication later, we'll find that multiplication is surprisingly not commutative. What would happen if we tried to do A plus C? We wouldn't be able to do it because the matrices are not the same size and shape. Subtraction works the same way as addition. Again, the matrices need to be the same size and shape. We take each pair of elements in turn. 2 take away minus 4 is 6. In the top right, minus 3 take away 5 is minus 8. 4 take away minus 1 is 5, and 1 take away 2 is minus 1. Unsurprisingly, matrix subtraction is not commutative, since ordinary subtraction is not commutative either. We can also multiply matrices by simple numbers, which are called scalars. If I want to do 3 lots of A, I just multiply each element by 3. So that gives me 3 lots of 2 is 6, 3 lots of minus 3 is minus 9, 3 lots of 4 is 12, 3 lots of 1 is 3. It doesn't matter whether you use square brackets or round brackets when you're writing matrices. I choose to use square brackets because I can write them more neatly. Pause the video for a moment while you work out minus 2 lots of C. OK, minus 2 lots of C is minus 2 times 3 0, which is minus 6 0. Let's look again at our first example. These matrices give us information about football matches. If you're not familiar with that, W stands for matches won, D for matches drawn, L for matches lost, F for goals scored for, and A for goals scored against. City, Rangers, Town and United are just football teams. Here we've got the final matrix, and we've also got the matrix before the last 3 games were played. Can we work out those last 3 results if we know what the fixtures were? We can do this by subtracting the second matrix from the first matrix. Pause the video for a moment while you do that. OK, this is what you get. 4 take away 3 is 1, 1 take away 1 is 0, 1 take away 1 is 0, 12 take away 10 is 2, 8 take away 7 is 1, and so on. Can you now work out what the scores were for these last 3 matches? City played just 1 game and they won it. They scored 2 goals and 1 goal was scored against them. So the first match, City versus United, must have been 2-1. Town also only played 1 match, but they lost theirs. 1 goal was scored for and 2 goals were scored against. So we can put that score in. Rangers played 2 matches and we've already dealt with the one that they won. They drew the other match. Altogether 3 goals were scored for, so that leaves 1 goal for this final match and 1 goal against. We can now check that United's matches are correct. They played 2 matches, they drew 1 and lost 1. And 2 goals altogether were scored for and 3 against. There are more notes on integral on basic operations with matrices. That's the end of this short video. The next video in this series is on multiplying matrices.